Okay, dear Finite Math students, let's work on some problems in chapters 3 and 4. And as usual, I'm going to use Mathematica instead of a calculator. And yes, I'm a big advocate of Mathematica. I think it's a wonderful tool. It's much more powerful than even the best calculator out there. Um, yes, you can use a calculator in the course if you really want to, but my recommendation is that you use Mathematica because Oakton College has a site license with Wolfram Research, the company that distributes Mathematica, that sells Mathematica. There are many teachers at Oakton that like to use Mathematica. I'm certainly not the only one. We have many math and physics teachers and computer science teachers that like to use Mathematica. So my recommendation is why don't you give it a try? At least use it for some of the homework problems. Maybe not all, but you should try it for some, okay? So let's launch Mathematica. Okay, so let me see here. There we go. Let me see. Okay, Mathematica. This doesn't make any sense. Why does it say your license will expire on June 28th, 2022? Yeah, that's kind of weird. This should be a permanent license. So, guys, when you have issues with your installation, like I have an issue here, it says your license will expire on June 28th, 2022. If there's an issue, and that I shouldn't be getting that warning message. So, if there's an issue like that, make sure you reach out to customer service at Wolfram Research. Make sure you reach out and let them know, okay? So that warning message looks a little weird to me. I should not be getting that message. So make sure you you reach out to the company and say, contact someone in customer service and say, excuse me, but what's going on here? Why am I getting this message? Okay. If you're getting a message like that, it helps to have your license ID. And how do you get your license ID? Well, let me see here. Edit style sheet. Okay, input, output. Okay, so these are a little bit, okay, they're too, cancel. No, 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 no. Okay, these are a little too small. So let's say format, show fonts. That looks good. And Arial, they're both bold. We could make these even just a teeny bit bigger. How about 26? Okay. And we could choose, midnight blue. And the output could be, plum. It's a reddish purple. Okay, that looks fine. Okay, so now we're ready to go. So if you want to see your license ID, you have to use this command. All right, and then press Shift Enter. I'm not going to press Shift Enter because I don't really want you to see my license ID. Okay, that's personal information, right? It has to do with my copy of the software. It's my copy. But if you enter the $sign, all right, and then type license ID, capitalization does count in Mathematica, capital L, and then, capital I, capital D, okay? So if you press Shift Enter, that will tell you the license ID for your copy of the software. And then when you communicate with customer service at Wolfram Research, make sure they have your name, your email address, and of course your license ID. Okay? And it's as simple as that. Okay, so let's take a look at this question. We're doing question 76 in chapter 3. How long will it take money to triple if it is invested at 7% compounded semi-annually? What about 8.5% compounded continuously? Okay, so let's answer the first question. So we have, let's think about what's actually happening here. So I'm going to define a function, f of x. You can call it whatever you want to call it. Math teachers love f right here. We don't need to see the pop-up window here. Okay. And 7%, we change it into a decimal. We change that into a decimal. And we should divide by 2 because semi-annually means twice a year. And then, of course, we have the 1. We always add the 1 because we're dealing with money. We always add that 1. Okay. And that's going to be, the previous balance. So actually, this variable here, this could be month. This could be month, and we could say month should be, oh, actually, no, sorry. This is not months. Semi-annually means half a year. So 6 months. So really, I should just say period. And of course, the period has to be bigger than 0. You don't have to put that in, but it doesn't hurt. And this is going to be period minus 1. Okay. And initially I will have, let's say, $100. I'm going to have $100 in here initially. Shift enter. Okay. And remember, each period is supposed to be 6 months, twice a year. Okay. So this is called a recursive definition because the money I have each period is based on how much money I have the previous period, which makes sense. Okay, so let's see. F of 0 should be $100. 6 months later, I have that much money. And then 12 months later, remember each period represents 6 months. I have that much money. So I want to know, how long will it take money to triple if it is invested at 7% compounded semi-annually? Okay, so eventually this is going to turn into $300. This is going to turn into $300, and we can see that if we use the table command. Table f of period, and I'm going to take a guess. Period goes from 0 to 100. But I also want to see the number of periods. I would like to see the number of periods, right? And this f of period here, let me expand the window a little bit. It would be nice if we could round to, 2 decimal places, right? So number form infinity to, okay. Wait 1 moment. Here we go. There we go. All right. And let's see what we got. Yeah, we would like 100. Hold on one second. What's going on over there? Let's pause the video. Okay, we had a little emergency in the kitchen. Sorry about that, guys. You know, for this one, I think I want this to be a decimal number. That might look a little bit nicer. Let me start over again. I could go up here and clear F, Shift Enter, and F of 0, yeah. And there we go, and there we go. And let's see. I'd like to see this $100 with 2 zeros. You know, it would look a lot nicer. Yeah, that looks much nicer. Now I have 2 zeros. I mean, it's not the end of the world if you have your 2 zeros or not, but you know, that looks nice. You could probably, well, anyway, we should get back to the problem. We don't have to spend a lot of time on formatting. Okay, what's happening in the kitchen? Okay, let me pause the video. Okay, let's try this again. Okay, so you could probably add dollar signs maybe. If you wanted to add dollar signs, let me see. You could do dollar sign and toString. Let me see what this does. There we go. Well, that looks kind of nice. Okay. Okay, so how many periods does it take to reach $300? Right over here. Right over here. Right over here. Now the question, okay, so the question with your homework, I have a feeling there are different ways of looking at this problem. Okay, do they want this answer or do they want this answer? Now, personally, if I was writing an exam, you know, I would be perfectly happy with either answer. Probably, you know, 32 periods is what I would really prefer. However, I have a feeling that what your homework is looking for is an answer between 31 and 32. So if we have 2 points, 31, 290. Okay, so we have 2 points and 32. 300.67. So then, you know, obviously 31 point something will give me 300. Okay? So how do we figure that out? Well, this is simple. This is college algebra, right? So we can use, you know, the equation of the line mx plus b, and m, the slope, is going to be 367 minus 290 50, and that's divided by 32 minus 31, which of course is 1. Okay, so what is that going to be? Let's see. So that is going to be m is equal to 300.67 minus 290.50. And you know what? We could do it this way. Make it look pretty. Highlight it. Control divide by 32 minus 31. 10.17, and that's the slope, right? That's the slope of the line. And then what about the y-intercept? Okay, so that's going to be, b is equal to y minus the slope x. And that's going to be b. So b, well, it's a little, there we go. B is equal to, pick a point. It doesn't really matter which point. I'll pick this one, okay? It doesn't matter. Either way, you get the same answer. So B is equal to, Y is 300.67. 300.67 minus M times X, which is 32. So 300.67 minus M times 32. And that's, okay, so the slope is 10.17 and the y-intercept is negative 24.77. And this is the equation of our line. So then we could turn to Mathematica and we could ask the question, well, this is a little harder to see. Okay, solve. When is 300, notice the double equal sign. When is 300 equal to, let me see, how do I want to write this? Well, hold on one second. How do I want to write this? Hold on. So y, here, we're going to use this, hold on one second. We're going to use this equation. And let's say this is 300. This is 300. So we're going to use the equation solve. When is 300 equal to m times x plus b? What is x? And I like to use flatten with my solve command. You don't have to, but I prefer to. I think it looks nicer. It's about 31.93. Okay, so that's 31.93 periods. Now this is important to remember. Each period is 6 months. Each period is 6 months. So it's about 31.90, well, how many decimals do we really want, Okay, so we have 31.934, etc., and I can do this. Well, I could just take this number. Copy and paste. Oh, wait a minute. Why is that not? Oh, copy. Here we go. Copy and paste. There we go. So this is the number of periods, right? So if I have, let's say that I have 2 periods. Let's say I have 2 periods, right? So how many years is that? How many years is that? Well, each period is 6 months. So 2 periods is the same as 1. Hold on, guys. My dog is like bugging me here. Come on, Chach. I can't play with you now. Sorry. So each period is going to be 1 year. Each period is 1 year. I'm sorry. Each period is 6 months. So 2 periods. Okay, I cannot play with you right now. Come on. Sorry, guys. My dog is kind of hanging around me and bugging me. So each period is 6 months, right? So there are 2 periods in 1 year. There are 2 periods in 1 year. So if 2 periods is 1 year, I have to divide this number by 2 in order to get the number of years. Okay, oops, wait 1 second here. Divide by 2, right? So then I'm going to take this number and divide by 2. Well, you can't quite see it. There we go. So it's about 15.967 years. Now, I was rounding out to, I rounded out everything to 2 decimal places. Hopefully that'll be enough to satisfy Mathematica. Not Mathematica, but Pearson. Sorry about that. Let's see what Pearson has to say. Hold on 1 second. Let me get rid of that. It will take about 15.97 years. It will take about 15.97 years at 7% compounded semi-annually. And yeah, so, Pearson's making the problem kind of tricky, because they want you to do something called linear interpolation. And linear interpolation basically means I know that the answer is somewhere between 31 and 32, and then you're going to have to figure out the equation of the line in order to find the exact intermediate value where it's going to be equal to 300, right? So is the answer 31 or is it 32? And the answer is really in the middle, right? It's about 31.93. But then you have to change the number of periods to years, which means you have to divide by 2. Okay, so it's a little bit of work, but you can do it. You can do it. Or use the formula in your book. You can also use the formula in your book. Okay. Now here, it will take about how many years at 8.5% compounded continuously? So this one's a little trickier. Well, not really. Not really. For this one, we're not dealing with discrete periods of time. Okay, so the word continuous, we're not dealing with discrete periods of time. Okay, that word that I'm using, guys, it's discrete. Okay, discrete. So what is discrete? So discrete means like you have 12 months in a year. You have 5 children in a household, or you have 12 eggs in a dozen eggs, or you have a box with 100 cookies. Okay, those are examples of discrete quantities that can be described with just regular whole numbers or integers. So when you have something like this, right, continuous interest means the interest is not being earned every 6 months or, every month or every day or every hour or every second. It's being earned continuously, like every microsecond, even faster than a millisecond, even faster than a microsecond, right? So for this kind of thing, solving the problem like this could be, kind of challenging. It actually could be done, but it's not going to be so easy. This is actually pretty easy, but okay, we have issues in the kitchen today, but okay. This is, teaching from home is always a little bit of a challenge, okay? So for this one, guys, I think it's better to use the formula in your book. So what is the formula in your book? So what we're going to do is, the formula says that the principal, again, I'm going to define a function. Okay. Should we use time? Yeah, let's use time. Okay, so the principal as a function of time is going to be equal to, this is principal as a function of time. Principal as a function of time is equal to the number e. Now, what is the number e? The number e is approximately 2.718 to 8182.846, but it actually goes on forever and ever, just like the number pi. So this is going to be 0. Let me see, 0.85 multiplied by time. Notice you have a choice. You can use the star symbol for multiplication or just use a space. Time. And this will be my amount. How about we start with $100? And when does it become, $300? Because it says here, how long will it take money to triple? So if you start with $100, when does it turn into $300? Okay. Okay, 1 second here. So what do we have here? Let's see. Okay, so after 1 year, oh, wait 1 second. Why is this an issue? It's not evaluating. Hold on 1 second. Shift enter. There we go. Make sure you press shift enter at the end of these commands, okay? That's important. Okay. So let's see, after 1 year, after 2 years, after 3 years, after 4 years, etc., etc. And eventually it'll turn into $300. So solve p of time, and you don't really have to use the variable time. You could use any variable you want. P of x. When is it equal to 300? And I'm looking for x. It's about 12.92 years. Round to 2 decimal places is needed. 12.92. There we go. Excuse me. Okay, so, and if I don't know how to do the problem, open up your textbook, look at a video, help me solve this, view an example, send me an email, okay? So you have some choices, right? You have some choices. Okay. Let's go on to a problem that's, maybe a little more challenging, because this one it's not that bad. I thought it was a little easy. So let's go on to a problem that's a little more difficult. We can do this one. Well, yeah, we could do this one. This one's going to be, you have to find the rate, and that's going to be, it's going to be a little bit tricky. Find I the rate and n the number. Oh, this one's actually not tricky at all. This one's, okay, this one's actually pretty simple. So this one's very simple. So it says find I the rate per period and n the number of periods for the following annuity. So quarterly deposits of $800 are made for 5 years into an annuity that pays 5.5 or 5.5% compounded quarterly. So here we're simply, so the interest rate is simply going to be, well, Well, I don't know if they're adding one. Are they adding one or not? So if you have 5.5, you're going to change it into a decimal by dividing by 100. And then you divide by 4. Because the deposits are quarterly, you have 4 quarters in a year. Okay, so I don't know if, well, it says they want an integer or decimal rounded to 4 decimal places as needed. So this, okay, if they're not including the number 1, and they're supposed to, but maybe they're not, it would be 0.0138 if I'm rounding to 4 decimal places as needed. Yeah, so normally but really when you're solving these problems, guys, you're supposed to add the number 1, but they neglected to do that. But you are supposed to add 1, so it's 1.01375, and of course they're rounding to 4 decimal places, so it's 1.0138. Okay, that's fine. So actually that problem is kind of easy. And what is n, the number of periods? Well, 5 years, there are 4 periods in a year. 5 times 4 is 20. So that's pretty easy. Not much to do with that problem. Okay, so simple, straightforward. Let's do a problem that's a little bit more challenging. Let's see. Okay, so here we have a problem for you finance people, for you business majors and finance students. This is this is definitely a fun problem. So use graphical approximation techniques or an equation solver, so we really have to use Mathematica for this problem, to approximate the desired interest rate. Yeah, so this problem is definitely going to be challenging. An employee opens a credit union account and deposits $140 at the end of each month. After 1 year, the account contains $1,686.33. What annual nominal rate compounded monthly has the account earned? So what they're talking about, okay, and see, again, you can use, I'll show you how to set this up, but the problem is if you don't know the interest rate, it's a little more challenging to solve the problem, but we're going to figure it out. So balance 0, we start with nothing. We start with no money. Start with no money. Okay, start with no money. I'm going to call my function balance. You can call it whatever you want to call it. You can call it f or g or y, or you can call it BAL, B-A-L. You can call it b. Give it any name you want to call it. Give it any name you like, okay? And then balance, and we're talking about months here, and you need that underscore because we're talking about an argument to a function, right? And the month is going to be greater than 0. I think technically you don't really need to put in month greater than 0, but I think it's a good idea, okay? It doesn't hurt. And here, what is the interest rate? Let me see here. So what is the interest rate? We don't know the interest rate, right? So interest rate divided by, the interest rate's a percentage, and we're going to divide by 400. Now, why are we dividing by 400? You have to divide by 100 to change the interest rate into a decimal because the interest rate is expressed, it's usually expressed as a percentage. So you divide by 100, okay, you divide by 100 to change the percentage, into a decimal, and then you divide by 4 because it says here that, oh, sorry, no, you divide by 12. Sorry, you divide by 12 because the interest is being compounded 12 times a year or every month. Okay, so then we have times the balance of the previous month, and then how much money am I depositing at the end of the month? $140. And that's it. Okay, and then it says here, after 1 year, the account contains $1,686.33. So balance 12. So it's a really complicated algebraic expression. Let's simplify it. Expand. Okay, so it's pretty messy. I mean, it's pretty messy. But using Mathematica, you can solve this equation. You can solve this equation. So what we're going to do, rather than using solve, I'm not going to use solve. I'm going to use find root, because solve may not give me what I really want. So what am I solving for? I'm solving for I. I know I is between 0 and, I don't know, let's say 0% and let's say 50%. 50% seems like a lot, but I have to provide a range. Like, I think my answer is between 0 and 50. And as always, I like to flatten my answer, which means getting rid of extra list braces. Okay, so that doesn't look so good. Why am I getting negative 2,400? That doesn't quite make sense. Oh, of course, because equals $1,686.33. All right, yeah, okay, that makes more sense. Let's try it again. Okay, so I'm getting I is equal to 0.8202. That seems pretty small. Hold on 1 second. Let me make sure. That seems really kind of small. Round the final answer to 2 decimal places as needed. Round all intermediate values to 6 decimal places as needed. That seems a little, hold on 1 second. That seems a little bit small. 0.82%. Yeah, okay, it works. That just seemed that seemed really small, but okay. That works, not a problem. Okay, so there you have it. Okay, yeah, 50% is way too big because, well, and the reason, so if you're depositing $140, if you're depositing $140 a month, ugh, my God. If you're, okay, shush. If you're, Chachki, shush. If you're depositing $140 a month for 12 months, okay, I would expect a total value of $1,680. What I have here, though, is $1,686.33, which is not a big difference. So actually, that's a difference. If you think about it, that's a difference of what? $6.33, which is really, that's not a lot of interest. So yeah, it makes sense that the nominal rate is going to have to be pretty small. It's pretty small. It's not even 1%. It's 0.82%, which is really kind of small. Okay. All right, let's try one more, guys, and that's going to be enough for today's video. I will do more of these videos for you. It's just difficult to make really long videos because I have a very noisy household and there's a lot of stuff going on here. So it's better to make, shorter videos. So let's try another one of these problems. Let's try a mortgage problem. Those are kind of interesting. Those are fun. let's see. This is an annuity problem, so it's not, okay, let's see. Okay, so this problem is really, this is a fun problem. This is number 138 in your chapter 3 homework. This is a challenging problem. This is a challenging problem. So let me just put the video on pause a moment, and we will continue in just a few minutes. I just want to see what's happening in the other part of the house, okay? Okay. Hold on 1 second. Let me just pause this, and we'll be right back in a few minutes. Okay, guys, let's just do one more problem, and then we're going to call it quits for this particular video, okay? A family has a $147,008 25-year mortgage at 7.8% compounded monthly. So this problem is divided into two parts. Find the monthly payment and the total interest paid. Okay. Suppose the family decides to add an extra $100 to its mortgage payment each month, starting with the very first payment. How long will it take the family to pay off the mortgage? How much interest will the family save? Okay, so this is a pretty robust problem. So again, as always, we're going to use Mathematica to help out. Okay, 1 second. Let me just get my power cord out of the way. Okay. I'm going to scroll down. So 7.8% compounded monthly. Okay, 7.8 divided by 1,200. 1 plus. So this is my interest rate per month. Okay. 1.0065. All right, so clear balance, because I want to use this again, or redefine the function. So balance month, that's going to be my rate times the balance of the previous month, okay, minus my payment. And I don't know what my payment is going to be. I don't know yet. All right, and then balance of 0 is going to be $147,008. Okay. So it's a 25-year mortgage. How many months are in 25 years? Okay, so balance of 300 months. Let me try, what happened over there? Why am I getting a sound like that? Balance of 300 months. Oh, that's interesting. My computer's talking to me. Okay, great. Getting clicking noises. Okay, so it's a really long. Okay, oh, I see. Max format depth exceeded. Not a problem. So let's, expand it. Or we could full simplify it. Expand it, full simplify. I think the results should be about the same. Okay, so here, let me just put the laptop back on the table and move my power cord. Okay, so this is my equation, right? Now, I know that after 300 months, this equation has to be equal to $0 because I will have paid off my entire mortgage. So that means we're going to use solve. All right, let me use parentheses just in case. I'm going to use parentheses is equal to $0, and I'm looking for payments. What is my payment? Let's see. So my payment is about $1,115.22. monthly payment is $1,115.22. Okay, so Pearson accepts my answer. And guys, yes, occasionally I do make mistakes. I mean, I don't, I know the material in this course pretty well because I've taught this course many, many times, but once in a while I still do make mistakes, okay? We're all allowed to make mistakes once in a while. But I know this course material pretty well because I've taught it at least a dozen times already. Okay, so what is my total interest? So think about it. What is your total interest? Well, how many checks for $1,115.22 have you written? You've written 300. So 300 times $1,115.22. And what did you actually borrow? You borrowed $147,008. That's what you borrowed. So your total interest is going to be $187,558. That's your total interest, $187,558. And that is correct. Okay, so now B, suppose the family, see now this, again, my personal opinion is the authors of your math textbook are making Part B a little more complicated than necessary, but that's okay. I would be happy with an integer answer, but they want you to be very, very specific here. So it says here, suppose the family decides to add an extra $100 to its mortgage payment, which means obviously you'll spend less on interest, and you will finish paying off your mortgage before you reach the 25-year mark. So first of all, let's define payment, because right now payment it's not defined. It's an algebraic variable. Okay, what is payment? Payment is a symbol. It's an algebraic value. It's a symbol. But if we do this, what is the head of 2? That's an integer, right? What about 2.2? That's a real number, right? So, Mathematica has different types. It has different types. So here we need to define payment, all right? So payment is going to be equal to this value. Well, should I use, maybe I should just use 1,115.22. Let me just, round out to 2 decimals. Although, should I really use... Now, this is something I get confused about. Should I use 2 decimal places or should I use all the decimal places? This does get tricky. Let me use all the decimal places. Let me use all, although maybe... this does get very tricky. I'm going to use 2 decimal places. Let's see what happens. Let's use 2 decimal places, okay? Excuse me. 2 decimal places, but we're adding $100. We're adding $100 because we're paying $100 more every month. Okay, so I'm paying $1,215.22, which means for 300 months, right, they owe me, right, the bank or the savings and loan or the lender, the insurance company, whoever gave me the money for the mortgage, they owe me $92,065.33. Okay, so the question is, when is this going to reach 0? Well, let's check it out. Table, balance, month, where month goes from... Okay, I'm just, hold on one second. I'm just listening to stuff going on in the household. Sorry about that, guys. Okay, so let's see what we have here. Table form. Okay, so let's see. At 0 months, I owe $147,008. And 1 month later, I owe this. And okay, blah, 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 blah. When do I owe 0? When does this actually go to 0? Okay, it goes to 0 right about here. Okay, so again, we have the same thing as before. Okay, so the answer is going to be somewhere in between 239 months and 204. Oh, wait, sorry. No. 0. Okay, so 0. The 0 is between 238 months and 239 months. So 0 is in between 238 months and 239 months. Is closer, a lot closer to 238. But we have to do this the official way. Because otherwise Pearson is not going to like our answer. Okay, so let's see, 238 and 239. Okay, so 0.1 is equal to 238 balance of 238. And then 0.2 is equal to 239 and balance of 239. There we go. Okay. And we want to find, it's called linear interpolation. Okay, let me spell this out. Linear interpolation. Linear interpolation. It's called linear interpolation. So we want to figure out at what value are we going to have $0? It's 238 point something. 238 point something. Let's be more exact, okay? We could guess, but let's try to be more exact, okay? So again, let's use y is equal to mx plus b, all right? So the slope, well, I'll just call it slope, is equal to this number, copy paste, this number minus this number. Okay, that's going to be the slope. Control divide by, and that's going to be 239. Okay, minus 238, which is really the same thing as 1. And if you divide by 1, nothing really changes, right? So you really don't need that, right? So the slope is negative 1213.66237482. Okay. So then we need to figure out, again, I'm using y is equal to the slope, right, times x plus b. So then b is equal to y minus slope. 1 second here. Why is this? Okay, b is equal to y minus slope x. Okay, looks good. Okay, terrific. So pick a point. It doesn't matter which point. So the intercept, or b, same thing, okay? It's going to be y. I'll pick this point, 0.2. This is y. Copy paste. Okay, minus my slope times x times copy paste. And remember, you could do this or just space. Okay, and that's my intercept. Okay, so then we're going to have solve. When is this equal to 0? Slope times what number? I'll just call it what number. Slope times what number plus intercept. And I'm looking for what number. And actually, guys, You know what? Why does it have to be help? Let me see something. No. Let me see. Global symbols that have no value assigned. Yeah, let me make that red, or maybe a reddish color. How about red? We like red. Global symbols that have no value assigned. Okay, why didn't that change? Wait a minute. I'm just playing with my preferences, guys. I'm just trying to change the numbers. I mean, not the numbers, but the values, the local variables. Oh, this is why. This is, hold on a second. You know what? Let me, actually, okay, I'm going to go back to blue. Local variables, table, we can make this red. Let's make that red. There we go. Okay, so now it's red, so you can really see it. You can really see it. Okay, so what number is about 238.19? Okay, so this is months. This is months, okay? So how do you change months into years? You have to divide by 12. So copy, paste, all right, divide by 12. It's about, more or less, like, it's almost 20 years. It's like, 19.85 years. Round to 2 decimal places. 19.85 years, round to 2 decimal places. Okay. So now we have to think, what is our total interest saved? What is the total interest that we're saving? Okay. So hold on one second. So this one can get a little bit tricky. Okay. So here, this can get a little bit tricky. Okay, let me think for a moment. So here, 238, 239. The total interest. Okay, so our payment, hold on one second. Our payment is that, right? So it's going to be our payment times 19.85 years times 12, because we're actually paying every month, so you have to change years into months, minus how much did you borrow at the beginning, and that's going to be balance of 0, which is actually equal to this amount of money here, $147,008, okay? All right, so it's about $142,457 and like 40 cents, more or less. Okay. How much interest are we saving? Well, this is what we paid in interest before. So what we're going to do is take this number right over here. We're going to take this number here, right? And then we're going to do $187,558 minus this entire value, and I have saved $45,100.60. $45,100.60. And there you have it. So it wasn't that bad, was it? I mean, These are fun problems to do. Um, I think they're really interesting and they're useful. I mean, you can do a lot of stuff with these problems. Um, Certainly, guys, if you're interested, hold on one second. Excuse me. If you're interested in business, if you're going to major in business or marketing, finance, accounting, you need to be pretty savvy with numbers. You need to be good at math, okay? You don't have to be Albert Einstein, but you have to be good at math. You have to be very good with numbers because otherwise, well, don't major in business, I mean, you have to be pretty good with numbers. And so, yeah, I strongly encourage you guys, and please develop, your mathematical maturity because it's going to pay big dividends when you study business. The stock market, commodities market, the real estate market, whatever market you're going to study. And money, they say money makes the world go round, okay? So, and that's probably very true. And in order to study money, you have to be very well grounded in higher mathematics. So, I know this course may seem intimidating for some people, especially since you're doing it in 7 weeks, which is very difficult to do. Um, I certainly don't envy you guys. This is a very hard course to do in 7 weeks. And we have to cover a lot of material. But if you're going to transfer into a college of business, you need to be well grounded in mathematics. You need to know your algebra. You need to know your statistics. And quite frankly, guys, you should even know some calculus, okay? It will help you. It will really, really help you. A lot of people think, well, I want to become a business manager. And if you're a business manager, all you have to do is just count the money in the cash register, hire people, interview people, hire people, and fire people, and that's all you do. And actually, that describes a pretty small percentage of business people. So there are a lot of business people out there that really have to know a ton of math. So, the retail assistant managers and stuff like that, maybe they don't have to know a lot of math, but there are business people out there, people who work for insurance companies, for example, they have to know a lot of mathematics. People who work in real estate, people who work in the stock market, people who work in the commodities market, okay? District managers of big businesses, companies, and corporations, they have to know a lot of mathematics to do their jobs, okay? So, now is the time. You're young, you're in college. Please learn this stuff. Learn it because it will help you later on, okay? You could learn it when you're older, but it's easier, I think. It's better if you learn it when you're younger, okay? All right, guys, I think this video is long enough. How long is this video? It's a little over an hour, so that's enough. So I will continue posting videos, and hopefully, I do hope these videos are helpful to you. If you would like me to work on a specific problem, if you need help with a specific problem, just email me and ask me. Email me and ask me, Mr. Lewitt, can you do problem 10? Can you do problem 90? I definitely will not be happy if you ask me to do 50 problems for you. You can ask me to do 2 or 3, but please, guys, don't overdo it, okay? Don't send me an email asking me to do, an entire homework assignment for you. I will help you with some of it, but I'm not going to help you with all of it, okay? This is really an independent study class. This is an asynchronous class, so you're really kind of on your own. I can help a little, but the student here, in this type of class, the student is really kind of on his own or her own. And it's hard, it's hard, okay? I'm not gonna lie to you, it's definitely a hard way to study. Okay, guys, all my best. I hope you have a wonderful week, and I hope you're having a fantastic summer, and we will communicate very, very soon, okay? Take care. Bye-bye.